Welcome to the Padhai Kar Lo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is the properties of binomial coefficients, the elegant identities that go well beyond the basic binomial theorem itself. Let's begin. The sum of all binomial coefficients in the expansion of a plus b to the power n equals 2 to the power n. This is found genuinely simply by substituting a equals 1 and b equals 1 directly into the binomial theorem. The sum of coefficients at EVN positions equals the sum of coefficients at ODD positions, and each genuinely equals 2 to the power n minus 1. This is found by substituting a equals 1 and b equals -1 instead, which forces the odd and even terms to cancel against each other, isolating this exact relationship. The symmetry property n choose r equals n choose n minus r means Pascal's triangle genuinely reads identically forwards and backwards and directly follows from the actual formula for n choose r itself. Pascal's rule states that n choose r equals n minus 1 choose r plus n minus 1 choose r minus 1. This is genuinely the recurrence that literally builds Pascal's triangle. Each entry is the sum of the two entries directly above it, and it can be proven directly using the factorial definition or through a genuinely elegant combinatorial argument about whether a specific single element is included in a chosen subset or not. The greatest binomial coefficient in the expansion of a plus b to the power n occurs genuinely at the middle term when n is even, specifically at r equals n over 2, and at BOTH of the two middle terms equally when n is odd, specifically at r equals n minus 1 over 2 and r equals n plus 1 over 2. This is exactly why the coefficients increase steadily toward the center and then decrease symmetrically afterwards. A genuinely frequently tested JEE technique involves choosing specific, clever values to substitute for a and b to derive a particular sum identity being asked for. If a question involves alternating signs, try a equals 1 b equals -1. If it involves coefficients multiplied by their own index r, differentiate the expansion first with respect to x before substituting specific values. This differentiation trick converts sum of r times n choose r x to the power r minus 1 / into a genuinely usable, directly summable identity. A frequently tested trap involves genuinely confusing the greatest binomial coefficient, which depends only on n and r, with the greatest TRM in a numerical expansion like 2 plus 3x to the power 10, which additionally depends on the actual numerical values substituted for the variables. These require genuinely different, distinct methods to find. Also remember that C of n, 0 and C of n, n both always equal exactly 1. These boundary values are worth checking directly whenever verifying a computed formula makes logical sense. Let's recap. The sum of all binomial coefficients is 2 to the power n, while even and odd position sums are each 2 to the power n minus 1, both found through clever substitutions of r and b. Pascal's rule n choose r equals n minus 1 choose r plus n minus 1 choose r minus 1 builds Pascal's triangle directly, and the greatest coefficient sits at the middle term, or terms, or the expansion. Choosing the right substitution for a given identity, and not confusing greatest coefficient with greatest term, are the keys to this topic. That's the properties of binomial coefficients. Keep the clever substitution technique and Pascal's rule sharp. They unlock nearly every identity-based question in this chapter. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.